Good evening. I have a microphone. But if you cannot hear me, say, Brian, we can't hear you. And then we'll get the other microphone. All right. Can you hear me in the back? So, my name is Brian Pulling. I am an alumnus of Ithaca College. I graduated in 2016 with my bachelor's in clinical health studies. I was also an aging studies minor, and I was fortunate enough to spend a good amount of time here at Longview. And so I'm really happy to be back tonight, so thank you for having me. Tonight we are going to be talking about aches, pains, and our magnificent brains. And I think they're really related, and I hope you'll think that too by the end of this. This is a beautiful image of a brain, if you can believe it. This is a real brain. This is a person's brain, but taken in a bit of a roundabout sort of way. So this is a special way of imaging the brain and understanding how the brain works. This specifically shows us the connections between the individual cells in our brain. And this was an image taken by Dr. Brenton Hordiker at the University of South Australia, which leads us into my next slide. Because I am from originally Ithaca College, but after that, I went to the University of South Australia. While I was at Ithaca College, I was originally training to be a physical therapist. And I was working with a lot of people here and downtown and up at campus who had pretty profound chronic pain. And anybody who has pain knows how impactful it can be on our lives. It really can have a profound effect. And I was troubled by this because my coursework didn't really give a clear explanation of what to do about chronic pain or about pain in general. And it seemed really complicated and used lots of big words like neuroscience and neurophysiology. And that was troubling. So I did some more investigating and I found a research group called BIM, or Body in Mind, at the University of South Australia, led by Lorimer Moseley and Tasha Stanton, and they were my mentors. And they taught me about how pain works, and they helped me understand some of the neurophysiology that we're going to talk about tonight, some of the history that we're going to talk about tonight. Now, once I graduated in 2019 with my master's, I went to Boston Children's Hospital and Harvard Medical School, where I worked as a clinical research coordinator. So there, my job was to carry out research, to do the research that other researchers had designed. And really our goal was to try to understand, why do some children develop chronic pain and others don't? What is it about some people that lead them to chronic pain and not others? And then also, we studied trying to develop new treatments for chronic pain for teenagers. And I found that really rewarding. But just a few months ago, I found out that the University of South Australia has offered me a scholarship to go back to Australia to do a PhD. Thank you. So I'll be headed back there in just a couple of weeks. So I appreciate you having me on a Monday, because I couldn't do a Wednesday, because I'm going to Australia pretty soon. If you have any questions, you can ask me today here during the talk, or I have an email address that I'm sure we can get to. Whenever you hear a talk from a researcher of any field, in any background, they should tell you about their conflicts of interest and disclosures. It's an important thing for researchers to tell people how they're funded and what their background is. So I'm going to do that a little bit for you now. The first is that I'm funded by a scholarship from the university, so it's in my best interest that my research goes well. Fingers crossed. I've also received funding from a textbook company because I co-wrote part of a textbook with Elizabeth Bergman, who's here tonight as well. And we were studying aging and trying to write a textbook chapter about that. I've also received funding from a magazine called Cosmos, and that was from the Royal Institute of Australia. And I wrote articles communicating about science to people. And I also work as a volunteer for Pain Chats and the Pain Revolution, which are two organizations designed to help people better understand their own pain and find resources to manage it. So that's a little bit about me. Now let's get into the science. We've got 1 hour on the clock, so we're going to talk about a brief history of pain science. We're also going to talk about some myths about pain and aging, so hopefully that'll be interesting information. And we're also going to talk about some of the latest research that I've been able to work on as well. I hope if you take anything away from this talk, you learn that pain is complicated. Everybody understands what pain means for them. As soon as I say pain, something pops into your head. I'm not sure what it is, but maybe it's a personal experience or the experience of a loved one or a friend. Very few people don't have pain. It is possible, but it's not very common. So most people have some connection to pain in their day-to-day lives. And And I also hope that you learn that pain is a protector. Pain serves a very specific purpose in our lives. And first and foremost, it's to try to protect us from danger, not so much just damage. And we'll talk more about that. So what is pain? That was the first question I posed. We all know what it is. We all have some experience with it, but it's very important. People who don't experience pain, sometimes there's a genetic condition where people don't experience any pain. But it's very uncommon because often those people don't live very long because they run into injuries and problems in their lives and they don't survive out of childhood because pain is really important. It serves a very important function in protecting us from damage. It protects us from danger, and research about pain is very exciting because it's new. Most of what we know about pain we've only learned in the last maybe 20 years. The previous 400 years, not a lot changed. But for the sake of the argument, let's go back. We'll start with the definition of what pain is. Pain is an unpleasant sensory and emotional experience associated with actual or potential tissue damage, or described in terms of such damage. That's the official definition from the International Association for the Study of Pain. And it's important because they note a few key words in here. First, that pain is an unpleasant sensory and emotional experience. It's not purely sensory. It doesn't only tell us about the state of our body tissues, but it also tells us about some other components of how our brain works. It's associated with actual or potential tissue damage. We don't actually have to need legitimate tissue damage to have pain, and the pain is still very real. That's an important factor that we found with recent research. And it's described in terms of such damage. That's the way we talk about it. Now, let's go back a ways to René Descartes. We're talking 1600s. René Descartes is a famous mathematician, philosopher, writer, teacher, scholar, and he talked a lot about a lot of different things, but one of those things is pain. In 1637, he wrote a pretty important paper. He wanted lots of people to be able to access it. He was French, so he wrote it in French. Most scientists at the time would write their really important papers in Greek or Latin, but he wanted the world to know about what he was saying. So he wrote it in French. It has a very long title. Discourse on the Method of Rightly Conducting One's Reason and Seeking Truth in the Sciences. A noble title if I've ever heard one. And in that paper, he said, "Je pense, d'où j'en suis." I do not speak French, so that's very wrong. But that's what he wrote. So you can read it there, that's what he wrote. But that wasn't enough, people weren't really getting the message, so in 1644, he wrote another book. And this one, he said, all right, I'll do the science thing, I'll write it in Latin. So this was a much shorter title, and much more serious, Principles of Philosophy. This is a big one, this is a textbook, this is serious business from René Descartes. And he wrote, Cogito ergo sum. Anybody speak Latin? Yes. Okay, cool. Well, I don't, so I had to translate it. And both of these translate into, I think, therefore I am. And we all know this one. This is a huge moment in philosophy, and really in health and medicine too. He was, for probably the first time, at least in Europe, defining what it meant to be a human being and what it required to be a human being. This had been done by the ancient Greeks and Roman philosophers, but he was updating it for the modern age. Now, Descartes, importantly, he was a philosopher, but he was also a Christian, and this really informed his philosophy and how we interpret it today. So keep that in mind. His big idea was mind-body dualism. He believed that in order to be a human being, we had a mind and a body, and they were separate but closely related. Whereas animals were purely machines, automatons. And he was inspired by the automatons of the day, things like this machine, which is technically a robot, but uses much more basic components than modern robots. And he found that there was something about animals that made them separate, lesser life forms than we are. And this was consistent with Christian ideology of that time in the 1600s. He believed that human beings were a higher order of life, which is sort of a humanistic philosophy, and you might have heard of humanism as another form of philosophy. He wouldn't go that far to say that human beings were better than other forms of life, but that they were different. That was his perspective. We have a mind and animals do not. That was his big idea. And it's important. It's not quite so simple, but that was his idea. Cartesian philosophy is Christian and sort of humanist. It's a little bit more complicated than that, but broadly he believed that we have a body, but also a mind or a soul, and that sets us apart from other life forms. That soul is what makes us have experiences and feelings that are complex, like pain. Humans are different than all other life. And pain is intrinsically tied to suffering in Descartes' view. An animal's display of discomfort is purely biological. He had this great story about what separated human beings from animals. And he said that if pain were separate from suffering, then it would be like him being a sailor on a ship, becoming aware of damage in his ship, but not particularly bothered by it. Human beings don't experience pain that way. Pain is deeply troubling. It necessarily alerts us and makes us respond. You can't ignore it. You can't get by and just observe pain. It's much more visceral than that. Now, Descartes had some other ideas too, which were a little odd. He went off kind of on a tangent about animal spirits, and he was wrong, but that's not the important part. The important part is that at that time, medical science had a long way to go. He described animal spirits as a very fine wind, or rather, a very lively and pure flame. And he believed it was a physical substance that moved through our bodies. Didn't really understand blood and things like that, but animal spirits made a lot of sense at the time. He said that the purpose of sensation was to inform the mind of what is beneficial or harmful for the composite of which the mind is a part. The purpose of sensation is to tell us about our bodies, which makes sense, and I buy that part of it. Pain is not purely a sensation. It is a sensory and emotional experience, and that difference is really important, and we'll talk about why. Now, this was Descartes' famous model of pain. He used this image to describe what pain is and how it works. This is a cherub sitting by the fire. And the cherub's foot is too close to the fire and it's going to be burned. And so the animal spirits move a message of pain from the foot to the brain, like this. Woo! Close, but not quite. And I'll tell you why. Pain is an output of the brain. It's something that our brain has to create as an experience. Information about our bodies goes up through the spinal cord into the brain, through nerves, which are like wires, which he realized. He realized that there was this complex processing system that allowed information from our bodies to get to our brains, and that was important. He just couldn't quite take it as far as we're able to now with modern science and medicine. So that's what we're able to do today. Now, essentially what he was defining was a term called nociception. Noci comes from the Latin to hurt or to harm, and it's importantly different from pain. Nociception and pain are not the same, and often they're confused in even neuroscience textbooks. This really bothered me when I was a student because I was learning about pain and trying to understand it, but it felt like some of the experts didn't even fully know what was going on. And that's kind of exciting because it means that we're still learning a lot in this field about how pain actually works in the first place. Nociception is the neural process of encoding noxious stimuli. So we have to come up with a couple more definitions here. Noxious stimuli is anything we expect should cause pain or might cause pain. And we expect that because there are special receptors all throughout our bodies called nociceptors. They're really danger detectors. And they're specifically tuned to look for particular types of damage. Things like heat or cold, touch or pressure, or chemicals that might be a sign of a tissue injury or potential danger. So really what we're talking about is danger detection. This isn't pain yet. Danger detection mechanisms, or danger detection messages go from the body to the brain, and then the brain has to decide what to do with them. This is the big leap in pain science that was made a few decades ago and we're really excited about. In the past, it's been called an unfortunate trivialization, that pain and nociception could be the same thing, is not an admirable simplification. Patrick Wall was really the grandfather of pain science. And he said that the labeling of nociceptors, or danger detectors, as pain fighters was not an admirable simplification, but an unfortunate trivialization. The difference between these two phenomena matter. It's important for the way that we treat pain, so highlighting it makes a difference in the way we study this. The writers of textbooks will continue to purvey trivialization under the guise of simplification, he went on to say. And they have. Most neuroscience textbooks do still conflate these to some extent. There was a recent issue of National Geographic about pain, and even there, they do the same thing. The experimental results show that the final analysis, in the paper he was writing about, that produces the perception of pain is not monopolized by the peripheral receptor properties of nociception. That's a really wordy way of saying that you don't need nociception to have pain, and you can have nociception without pain. They're not mutually exclusive. That's a big deal for researchers, because often we're looking for one or the other, and to know that they're not always going to be there together makes a difference in the way that we treat pain. And we have some examples of that. John Bonica is a fascinating man. John Bonica grew up on an island off the coast of Sicily. His family moved to Brooklyn when he was 5 years old or so. His father became a postmaster general in their neighborhood. And John, unfortunately, his father passed away when he was very young. So John had to start working to help support his mother and the family. And he took up lots of odd jobs, working in markets and as a shoe shine boy and a newspaper salesman, all while fully attending school. In high school, he started wrestling, and he got pretty good. And he started winning some championships, and he realized he could use that to make money to go to college. So he did. He went to college, and he became a professional wrestler, and he was a very good one, and he became light heavyweight champion of the world at one point, just for fun. So John Bonica is a really fascinating guy because he had an unusual path in pain medicine. Now normally, to become a doctor, it's a pretty consistent series of steps. It's usually 4 years of college, 4 years of medical school, a 1-year internship, and then several more years of residency in your area of specialty. That's typical. But not so for John, because John came up during World War II. And during World War II, things had to happen a lot faster. Training got pushed really quickly. So they cut the internship down to 6 months and 18 months of residency. And that's crazy because John was an anesthesiologist, which is a very complicated field of medicine. But he did it really fast and he was very smart. And in 1944, he went to basic training. His first job out of medical school was to be in charge of the largest military hospital in the US of the war. He was responsible, his title was Chief of the Section of Anesthesiology and Operating Theater of the Madigan Army Hospital in Fort Lewis, Washington. It was the largest hospital of the war, and he was responsible for 7,700 patients on any given day. He was the only pain physician in charge of 7,000 people. That's nuts. In order to keep up with the demands of his job, he had to develop new techniques, and he pioneered a lot of this field. So developing regional anesthetic techniques, sort of localized techniques that didn't require so much time and medical risk. He noticed something odd, though, while he was doing it. And he noticed that he had patients coming back from war who had amputations. And they were reporting something that didn't quite make sense. They were reporting a ghostly phantom limb. Now this is a picture of the first physician to define that term, a ghostly phantom limb. He was a Civil War doctor named Silas, and he had a patient who had to have his leg amputated on the battlefield and was still having terrible pain in the limb that he didn't have anymore. And that's very odd, because it doesn't quite fit with what we think of from Descartes, right? Descartes said pain comes from the limb and goes up to the brain. What if you don't have the limb? Where's the pain coming from? And this was Silas's and then later John's big dilemma. Clearly it shows us that there is a unified We are a unified mind-body entity. We are not merely our bodies or our minds, but the integration of both. And the integration comes in through this brain that we saw at the very beginning. All of these connections show the phenomenal complexity of the human mind and the human brain. There are around 86 billion neurons in our brains, just in our brains. And a neuron is the smallest cell of our nervous system. So neurons are the cells that communicate with one another to allow us to think and to feel and to move and to live. And there are a lot of them. There are another 86 or so billion support cells that help those cells do their jobs. Each neuron in our body can connect with hundreds or even thousands of other neurons around it. And all of those connections mean that we have trillions on trillions of networks in our brains that allow us to experience the world. The complexity is staggering. We do not understand it. The brain is very weird, and it's very exciting. Have you ever heard of neuroplasticity? Neuroplasticity is a buzzword. Alan Alda taught it to me on the Discovery Channel a few years ago. That was the first time I'd heard of it. And really what it means is that the brain is adaptable. Human beings are adaptable. We can learn and change based on changes in our environment, changes that we experience in our day-to-day life. This is a really important thing because it tells us that we're always learning and growing and taking on new information, and it affects us on a cellular level. That's pretty exciting. And it's also true for pain. I can give you an example of how complex this system is. So take a look at this image. Can everybody see that A is darker than B? It should be. A should look darker than B. If it doesn't, that's a problem. This is a test developed by Adelson. He's a researcher from MIT, and in 1995, he came up with this checkerboard test. And the goal was to test people's nervous systems to make sure that they were functioning correctly. And so people who can't see the difference between A and B actually usually go for a checkup. But A and B are the same, and I can show you why. When we add a little bit more context here, we can suddenly see that A and B are the same color. The interesting thing here is that we can't tell the difference without that additional context. And it kind of makes sense if you think about it, because our eyes, our visual system, are not very good light detectors or light meters. They're not really very objective. Light comes into our eyes and activates cells on the back of our eyes. That information is then sent to the back of our brains where it's processed. We're not merely getting a direct reflection of the amount of light, and that's what creates our vision. It's not that simple. Our vision is meant to be contextual and give us information about what we're actually seeing, what it means, and why it's important for our lives. So Adelson says that this test actually shows the effectiveness rather than a failure of the visual system. It's a good thing that we do see a difference between A and B when there isn't one. Because based on the available information in this image, it looks like they should be different. And that's important in our day-to-day lives. Now, the fact that they're not different means that this is a trick. And tricks are really fun in research. We like to use illusions to test our perceptual systems and see how people engage with the world. And so we can do that with pain as well. The reason all of this happens, the reason and the methods that we process our world are hypothesized to be through a neuromatrix. Ronald Melzack is another grandfather of pain science, and in 1990 he wrote maybe the most important paper in pain science called The Neuromatrix. And the neuromatrix is an idea, it's a conceptual model. It's sort of like a metaphor. It gives us an example of how our brains work. It's phenomenally complex, we know that, but that's not good enough. We want more information than that, right? We want to understand, why does this happen? Why does pain affect us in this way? Why does that visual illusion work in the way that it does? Why can't we tell the difference between A and B? And the neuromatrix helps us explain that. So with the neuromatrix, information goes in as inputs, is processed in the middle, and then comes out as an output. And we can give some examples of what that kind of information might be. So stuff that goes into the neuromatrix are things like memories, previous experiences, Sensations, our biology, information about our bodies goes into the neuromatrix. And body regulation or homeostasis, again, information about the safety and health of our bodies. All of this information gets processed by those trillions on trillions of connections in our brains, and it looks maybe something like this. So the purpose of this image is to show that information is cyclically and redundantly processed over and over and over again in so many different ways we can't possibly comprehend it. Again, this is a conceptual model, so it gives us an idea that the important takeaway is that information is processed a lot, in lots of different combinations in different ways. The outputs are equally complex. There are perceptions, things like our feelings, maybe something like pain, or ownership, or stiffness, or fatigue. All of these are perceptions, not necessarily objective assessments of our bodies, but subjective reflections based on information that went into the neuromatrix. And this isn't linear. This is what we call an emergent framework. We're not really sure why it happens, and it's hugely complex. But all of this information gets fed into the neuromatrix, and we have outputs like pain. Things like movement, the way we move and the way we engage with our world isn't always precise. It's based on context and information that we have around us. And again, body regulation and homeostasis. So processes that try to keep us alive, keep us healthy, all of these are outputs too of the neuromatrix. The purpose here is to understand the profound complexity of the brain. And it's really pretty magnificent. Now, we can simplify this a little bit and think about the neuromatrix as a protectometer. So this is an internal meter within our brains, within our bodies, that was first described by Butler and Moseley, who were two of my mentors. And they talk about this balance of danger and safety within us. We talk about things like safety in me and danger in me. And these are assessments within our bodies of whether or not we're safe or at risk for potential harm. And pain should be, at least in the best case, a reflection of that relative danger or safety. So, when we have more internal danger, the indicator would move up and we would have more pain. If our relative sense of safety is higher, then the indicator would move down and we would have less pain. That makes sense because pain is a protector. So if pain is functioning the way we want it to, it should be a reflection of our sense of danger or safety. We've got some examples of different DIMs or SIMs, danger in me and safety in me. And there are lots of different things that affect us in lots of different ways. Things that we hear or see or taste or touch. So hearing something, or looking at an x-ray could give us a sense of danger. I've got a bulging disc or degenerative disc disease. Those are things that might make us feel at risk or in danger. But hearing that your scan is all clear or getting a gentle massage might give you a sense of safety. Things that we do for pain in this context give us a sense of danger or safety. So only relying on pills and just knowing that that's your only option because that's what the doctor said, that doesn't feel very good. That makes us feel in danger. But gentle exercise and learning about pain and why it's there in the first place, that can give us a sense of safety and confidence within ourselves. And this has been shown to profoundly affect our experience of pain. Things that we say, oh, it's just old age, I've got fibromyalgia, that's just how it is. That is not a fun thing to have to say, and it certainly would make me feel in danger. Whereas saying, there's a light at the end of this tunnel, I understand what's happening inside me. Those are much more confident and safe sounding messages. The things that we say to ourselves matter because that information is fed into the neuromatrix. And there's a lot of neurobiology and science behind how this actually happens. There are other things too, things that we think and believe affect our experience. So believing that pain is forever and there's nothing I can do about it is certainly going to put us in a sense of heightened danger. Whereas knowing that broken bones heal in only 6 weeks gives us a much different perspective on our sense of safety. Here's a tricky one. Places that we go can affect our sense of danger or safety. What about going to the hospital? Sometimes going to the hospital is really a great thing because now we're getting the care that we need from the doctors. But sometimes being stuck at the hospital just feels terrible and you want to be anywhere else. And so some of these things might be both DIMS and SIMS. They might give us a sense of danger and safety at the same time. Now we're really getting into the complexity here. What about the people in our lives and the relationships that we have with others? Our nosy neighbor versus friends who understand us. Or out-of-date health professionals who don't understand how pain really works versus up-to-date health professionals who really understand what's going on. Things happening in our body, like feeling depressed and anxious versus feeling happy and optimistic. We don't always have control over these DIMS and SIMS, but we know that they profoundly affect us. And another tricky one, acute inflammation. This is the process that normally and naturally occurs in our bodies when we have an injury that allows us to heal. It's really important to letting us heal, but it can come with pain, swelling, redness, and feelings of discomfort. So that's a tricky one because while it might make us feel in danger in the short term, it's actually protecting us in the long term. And understanding that makes a difference to the way we experience pain. Let's talk about some myths. Because like I said, this is a rapidly evolving field. So some of these myths might be really surprising and might even contradict what you already know about pain. Because this is new and we're learning more about this every day. So these myths kind of get updated regularly. Pain is inevitable with aging. It's not actually true. Statistics show that pain is not a guaranteed part of aging. Sometimes we'll have more illness and maybe more surgery as we get older, but this isn't guaranteed. And pain is not worse in older age than it is in younger folks. In fact, actually, the incidence, the commonness of chronic pain is highest in middle age, and then it gets better as you get older, which is a little interesting. If you have some pain now, then you will have worse pain later. Not actually true either. This is a tricky one, because sometimes it feels like it. But pain comes and goes. It's a reflection of the current state of danger and safety. If that changes, the pain changes too. X-rays and scans don't actually relate very well to increased pain. And this was a big breakthrough moment. This is a chart from a really important study from only 2015, which compiled hundreds and hundreds of different data reports about people who had scans, X-rays, MRIs, CAT scans, things like that. And they broke it down by age. So these are age at the top and by sort of decades. So 20-year-olds, 30-year-olds, 40-year-olds, 50-year-olds, all the way up to 80-year-olds. And then these are different findings that are on imaging reports. So radiologists take these images and then they write what they see. And they see these types of things: disc degeneration, disc signal loss, disc height loss, disc bulge, things like that. They're very common. This study is really interesting because it shows us how common at different points in our lives. And it's a little bit surprising. We might expect that disc degeneration at 80 years old is around 96% of people have disc degeneration. But go back a little bit, and at age 30, 52% of people have disc degeneration. So that's pretty young folks having pretty serious findings on their X-rays. What about bulging discs, disc bulges? At 40 years old, 50% of the population has a bulging disc. Now, I've got a blue box right here, which means I haven't told you something. This study was fascinating because this was conducted in a group of asymptomatic patients. So these are people who don't have pain. 96%, or excuse me, of people who don't have any pain when they're 80 years old, 96% of them will have a disc degeneration. But then go back a little bit further again. At age 30, of all the people who don't have pain in their back, 52% of them will have disc degeneration at age 30. So clearly, changes in the tissues don't relate very well to pain. These are all considered now to be normal age-related changes, just like gray hairs. And gray hairs certainly don't cause very much pain. These are normal parts of aging. And while sometimes, yes, they do connect to pain, it's not a guarantee. That's the important thing. It doesn't automatically mean that you will have pain if you have a positive finding on an X-ray. Myth 3, toughing it out makes it easier to tolerate. So we can talk more about philosophy. Another type of philosophy talks about stoicism. And this goes all the way back to Aristotle. And he talked about staying strong, stiff upper lip, keeping it all locked inside, and just dealing with it, toughing it out on your own. Toughing it out does not make it easier to tolerate. We know that. Toughing it out can make it harder to deal with. It can make the symptoms worse, and it can lead to lots of other problems like lack of sleep and depression and anxiety. So seeking out an up-to-date healthcare professional is really valuable. Up-to-date health professionals can help. Myth 4 is that there's nothing you can do for it. So if you call the up-to-date healthcare professional, what are they going to say? Well, they're not going to say this. There are lots of things you can do for it. Because we're all adaptable. That's why neuroplasticity is so exciting. There are always new treatments and new ways of managing perceptions and outputs like pain because we're understanding them better every day. Your protectometer can change. Your internal balance of danger and safety is always fluctuating at every age. And the more information we can give our bodies about our internal sense of safety, the less pain we should feel. Whereas if we have more things in our lives that are causing us to feel in danger, we're going to have more pain. So it's like and neuroscientists like nociception because it's a little bit easier to study because pain is really, really complicated. So we can break it down and just focus on nociception. So Mosley and Arntz in 2007 did a beautiful experiment. It's one of my favorites. It was really what got me interested in pain science in the first place. And they knew that color is important in our lives. So red is something we might associate with heat, and blue is something we might associate with cold. The title of this paper was that the context of a noxious stimulus affects the pain it evokes. Beautiful title. Not too long, not too short. The context of a noxious stimulus affects the pain it evokes. So we know what a noxious stimulus is. It's something we expect to cause pain. And we're going back to that idea of context. Context changes the way we experience pain. And this study shows that in a really cool way. So this study was done on college students. They were normal and healthy, except that they volunteered for a pain study, which makes them a little bit weird, but in any case, they volunteered. And they went into the lab and they sat down and they were touched on the arm with a metal rod that was very, very cold. So cold that we expect it should activate danger detectors. Not cold enough to burn them, but cold enough that danger detectors are activated. And while they were being touched on the arm with that metal probe, a light turned on, and it was either red or blue. And this is where it got weird. So when the blue light was on, people reported very little pain, compared to when the red light was on, they reported almost double the pain. Now they repeated this experiment a few different times, so we've got multiple graphs here. And they really weren't expecting what they found. Pain unpleasantness was worse when the red light was on, and it was better when the blue light was on. And this is the kicker for me. This is the one that really blew my mind. When the red light was turned on, and they were touched on the arm with a cold probe, it felt burning hot. But when they were touched with a cold probe and a blue light came on, it just felt cool. Not too bad. What? That's so weird. Temperature is supposed to be objective. It's supposed to be very specific. We've got numbers, we've got dials, it's very detailed. And this shows that even something as specific as temperature can be modified by the context of just a light. Now, the interesting thing about danger detectors is they're not very good at telling the difference between very hot things and very cold things. They leave that to the brain. They figure, I'm going to look for stuff that might cause pain, and the brain can decide what to do with that. And so the brain uses information in our environment to contextualize temperature information, very hot and very cold information. So when we touch the stove, we know that it's hot, not because of the detectors in our skin, but because of all the other information going into our neuromatrix in our brain telling us that when I was a kid, Mom told me not to touch the stove because it's hot and I'll get burned. And it's red when it's on, and so I know it's hot, and so it's hot and I get burned, and it feels hot. Whereas ice is cold because it's blue and ice from the freezer, and we have lots of other associations with cold things. There are some weird examples like liquid nitrogen. Doctors use liquid nitrogen sometimes, and sometimes it feels, if you ever go to the doctor and they poke you with some liquid nitrogen, like it's really hot. It's actually really, really cold, but we don't have a really good frame of reference for what that is because it doesn't come up in our day-to-day life very often. So that's a tricky one. Now, I was involved in a study more recently, and this was an interesting study because it was a case study. So this is just one person. We were doing a larger study, and one person responded in a way that surprised us, so we wrote a paper about it. The paper used virtual reality. The experiment used, it was looking at people with knee pain, and we pointed a camera at their knee, and they were wearing goggles connected to a computer. The image went into the computer, and then was processed by the computer, and then they could see it in the goggles. So they were looking at their own knee, but we could distort the image and play with it a little bit. And you'll remember back from the illusion earlier that we like to use the visual system to change the way people see things. So that's what we did for this experiment. We showed people video of their own knees, but we changed the images. So for the first experiment, we didn't do anything to the image, we just showed them their knee. For the second experiment, we did a shrink illusion, where we pressed on their legs, and in the video, we made it look like their knee was getting squished together. Then we did a stretch illusion, where we pulled on their leg, and we made it look like their knee was stretching and getting long. And then we did one where we compressed their knee, and we made it look like the whole knee was shrinking really small. And we got some interesting results. So this was a study done on people with chronic knee pain. They'd had knee pain for many, many years. But one participant responded a little bit surprisingly. His pain doubled within the session while we were stretching out his knee. Just like that. It was a short experiment. And while we were doing that, his knee started swelling a lot, like almost an inch, which is a lot for a knee. You know, you don't expect your knee to grow an inch in an hour. So much so that we weren't actually expecting to collect data on how much the knee had swollen, but we needed to after this guy. When we did the shrink illusion, his pain didn't change at all, and the swelling actually went down. So this tells us really a lot about how the visual system is important in how we contextualize information about pain. His neuromatrix, his protectometer, saw that his knee was growing and getting bigger, and that must be a bad thing. I mean, how could it not be? And so he had more pain, and he had swelling, which is part of that healing response to tissue injury. When his knee went back to its normal size and even got a little bit smaller, the pain went down, and so did the swelling because he didn't need the protection anymore. The internal protectometer was changing right in front of our eyes. And now again, this was only one participant, but it does give us a lot of insight into how much we can modify these factors for people through treatments. And so this is one option that we're looking at as a potential treatment for people with chronic pain. And I'm going back to Australia in just a few weeks to get started. So I'll come back in a couple of years and let you know how we're going with that. Now let's go back to this question from the beginning. What is pain? We've got the definitions. We heard about Descartes. John Boniek was working on it. Ronald Melzack helped us out. But what is it really? Everybody knows what it is in their hearts. Everybody has an experience of it and has felt it or been affected by it. Gallagher, in 2012, was a researcher who wrote about this and said that pain is our most sophisticated protective device. It's an alarm system within our bodies to alert us to potential harm. Pain depends on how much danger your brain thinks you are in, not how much danger you are really in. It's not objective. Pain is inherently subjective and a reflection of perceived threat, not necessarily actual damage. And that's an important distinction, because if we're always looking for damage when a person has pain, we're missing a really important part of their experience. And so that's what we're trying to do going forward. I'd like to thank you all for having me today. And I'd like to thank everyone at IC and here at Longview for supporting me, as well as my supervisors, Tesh Stanton, Laura Mosley, David Butler, Mark Jensen, Felicity Braithwaite. Thank you all very much.
Will you take questions?
I will happily take questions from anyone who has them. I see one in the back right there.
I have a question. Why does our brain have to process things so many times? What's the use?
That's a great question. Caleb in the back asked, why does our brain process information so many times? What's the use of that? And it's a great question because not only does it happen many, many, many times, but it happens very, very quickly, like blink of an eye or even faster. I mean, milliseconds. And that's really useful because it allows us to respond to changes in our environment quickly. And that's important when we're trying to protect ourselves from an injury or a threat or something that's trying to hurt us. We need to be able to respond to it quickly. And it's why we're able to make decisions quickly and change our behavior very quickly in day-to-day life. So the brain is often called the universe's most complicated computer, or most advanced computer. And the reason we say that is because we just can't make one that's as good. The brain is so capable, and all of these connections are so tiny that we're not able to replicate them with computers or machines. And so we haven't actually seen a brain that works as well as ours anywhere else in nature so far, but we're going to keep looking and we'll see what we can do. Does that answer your question? A little bit? Yeah? Any other questions? Yes?
I have frequently been in a hospital and they show me a pain chart, you know, the little faces.
Mm-hmm.
And I have been aware often that I was experiencing something. I mean, my mind said, this is really, really bad, but it wasn't like a toothache. And I had to say how bad it is on the pain chart. I'm assuming there are different kinds of pain sensations or different sensations that perhaps don't feel like a toothache. How does the brain cope with that, and how do you, as a pain researcher, respond to somebody like me who says, look, this feels weird, it is not good, I want you to hold me up by my feet because that'll feel better, but it's not a toothache.
That is a brilliant question. Did everybody hear that?
No.
It was asking about how do we assess pain? How do we respond to it? And so in hospitals, you'll be asked, or in doctors' offices, they'll ask you to rate your pain or describe your pain. And sometimes it's really hard to do that with the type of scale that they give you. 0 to 10 doesn't always cut it, or using those faces doesn't always quite describe it quite well, or comparing it to something else isn't always helpful. As a pain researcher, my first job is to listen. So the most important thing that I know about pain, based on the current available evidence, is that pain is deeply personal, it's very normal, and it's always real. People don't fake pain. They just don't. We've got extensive evidence and data showing that the number of people that fake pain is so small, it's negligible. It's a rounding error. So when someone tells me they have pain, they have pain. And when someone tells me that they need to be hung up by their feet because that's the only thing that'll make it feel better, I believe them. My hope is, as a pain researcher, I can help understand not only why you're feeling that, but also how we can understand your internal protectometer. What's giving you a sense of internal danger or safety? Is it a tissue injury? Is there something wrong with your body that we need to diagnose and treat? And if not, then what can we do to help your neuromatrix, your protectometer, understand that you are actually safe even when it feels like you're not? It's not a straightforward process, so I don't have a straightforward answer because this is the big complexity here. The exciting thing about pain research is we recognize now that pain is far more complex than we've ever previously thought at any point in history. The problem is, now what? And so my work is trying to understand how we experience pain and how we perceive pain and what we can do to modify it. And there are lots of other people exploring different parts of pain research, but the most important thing is that your pain is personal and very, very real. It's a normal part of life, it's a good thing, we need pain, but it's not all in your head. You're not making it up. It's very real. And knowing that, making sure that other researchers and health professionals and students and just people in the community understand that, I think is a really important thing. I work with some volunteer organizations that are trying to help regular people understand that, because it affects our societies. I think learning about pain is good for society because it helps us all to understand each other better. Now, I also said that pain is personal. Everybody's experience of pain is unique and different because it's inherently my perception of my safety or danger. So no one else is going to relate to it exactly the same way. If I tell you that my pain hurts just like a toothache or hurts as an 8 out of 10, it does. But my 8 out of 10 is not necessarily yours. My toothache is not necessarily yours. And so understanding that it's a personal experience and a unique experience is an important part of that as well. Does that help answer your question a little bit? Any other questions? Yes?
I just want to have a question. She's not even, all I want to say, I'm thinking of memory.
Mm.
Now, could memory trigger a pain reaction?
That's a great question.
I had it yesterday or 100 years ago.
That's a really great, yeah, that's a great question. The question is, can memory trigger a pain experience? Can remembering something cause pain? And most simply, yeah, probably. Pain or memory experience is part of that neuromatrix. It's one of the things that we use to contextualize our experience. So it's some of the information that we have. We do know that memory plays an important role in pain, especially from childhood. So there's this wonderful researcher named Melanie Noel in Canada, and she researches early childhood pain experiences, specifically related to getting your shots as a baby or a toddler, which can be a pretty trying moment, certainly for the parents. But what she's actually found is that a child's memory of a painful experience, even as something as simple as a flu shot, can have a profound impact on their life forever. Really, the early experiences that we have with pain and what we learn from doctors and our parents at that early age affects our experiences going forward. We're also able to modify those experiences. So Dr. Noel's work is really interesting because she asks people to remember their pain, but gives them new context. So she does research where children are getting their flu shot once a year, and kid gets their flu shot, and then she tells them, wow, you did such a good job, you were so brave. And she'll ask them to rate their pain on that day, and they'll say it was an 8 out of 10. But if she follows up with them in 2 weeks, often their memory was that, oh, actually that was only a 4 out of 10. That didn't hurt that bad, as far as I remember anyway. Now they said on the day it was an 8 out of 10, and they felt it on the day, but their memory was that actually it didn't hurt that badly. And that's really interesting, and that matters in how physicians and parents interact with children, but also at any point during the lifespan, because we know we're constantly learning and adapting to new information. So yeah, memory is very important. Yes?
My question for you is that when you talk about memory, and Noel is doing this, Melanie Noel is doing this work in Canada, I'd like you to respond to that memory of children that have emotional pain. You know exactly what you're talking about, child abuse and neglect.
Absolutely. So the question was about emotional pain, child abuse, and neglect, and how that might influence children as they grow up.
Of course not.
Yeah, well, the answer is obvious. Yes, of course it matters. A lot of people like to make a distinction between types of pains. And the International Association for the Study of Pain does that to some extent. There are different terminologies about how pain arises, what causes it, things like that. But broadly, if you think about what pain is, it's a protector. Pain is a sophisticated protective device meant to protect us from perceived threat or harm. And so to differentiate between physical and emotional pain doesn't really tell us anything different other than that we're trying to protect ourselves from harm. And so emotional pain is just as real as physical pain. They're not really different, at least in terms of the neurophysiology and what happens in the brain. The causes and the information that's fed into the neuromatrix is different, certainly, because we don't necessarily have the same type of danger detectors at work, but we do have lots of other influences like emotions and traumas and things that affect us for very many years going forward. So differentiating between types of pain is less important than understanding the function of pain in the first place, which is always to protect us.
I'd like to make a comment on that.
Sure.
If you work in a school district or any place with children, and I know, I mean, my employer, I was working with social worker in the school district, and the principal was fine, but I had to report on the child abuse and neglect, and also other people in the staff on things. And the impact, I mean, it's like in the classroom, they tell the teacher back off, and I knew the night before what had happened. There's no excuse for the big. We got CPS involved, Tiger County's what I saw. But, you know, there's such a link to manage children, I call it, like, the emotional pain is terrible. There's me, why doesn't he care more about me than my own parent? And I think, oh my God, not that again.
Well, thank you for sharing that. Yeah. The link between emotional pain and early childhood experiences and how we grow up and how we mature is very clear, and the research is really detailed on that and complex. There aren't easy answers to the questions that arise there. Thank you for sharing that. Any other questions? Yes, in the back.
So as you say that a brain is adaptable, like, I know like sometimes when you experience pain, like we'll go like in like a fight or flight reaction, and like a long time ago, like we would go like fight or flight, like if our brain's adaptable, why do we adapt to like not that like a fight or flight, like a effective, and like for example, like we know that tigers have to jump like hard.
Yeah, that's a great question. So it's about why do we adapt and how do we adapt and why don't we adapt to some things but we do others. Part of it's our experience. We get really good at adapting to things that we practice. So you can think about it adapting or an adaptation to less intense things than a tiger attack, but to maybe like practicing your sport or playing an instrument. We get good at those things by practicing them because it makes the connections between the neurons in our brain, the cells in our brain, stronger. The more we use them, the better we get at using them. It's sort of obvious, but it's as simple as that, really. So if you were going to be attacked by a tiger a lot, you'd probably get really good at protecting yourself from it. You'd probably adapt to that specifically really well. But you probably find that you adapt to other things more easily because you practice them more. Exactly. The comment was that could be true of pain. I totally agree. There's some really fascinating research about sort of learning to be in pain. We practice experiencing pain the longer that we have it. And this is a big theory behind how and why chronic pain exists, because often chronic pain occurs in the absence of an injury. There isn't necessarily anything wrong, except that we have pain, and that's not a good thing. Clearly that's wrong. Pain is a protector, but pain is based on information that we get from our environment. So if information in our environment is telling us we need pain to protect us, and that information persists even when information about like a tissue injury or an injury has already healed, but other information stays, other DIMS, danger in the information stays, then we'll have pain, and we get good at being in pain, and so then we have to unlearn or relearn what it means to be safe, is really how I like to think about it. So often we learn what's dangerous, and it's not actually as dangerous as we think it is. And relearning what's safe can have a big impact on how we experience pain.
Can I just congratulate you on your acceptance into the PhD?
Thank you very much. That's very thoughtful. You congratulated me on the PhD. Thank you very much.
Very special.
Thank you. You have a question in the back?
Can you speak about labor pain?
Oh, that's such a good example. Labor pain is fascinating. John Bonico really worked a lot on this because Oh, this is fascinating. So she asked about labor pain. Labor pain is a really interesting example. So in labor, nociceptors, danger detectors are activated. We have seen that in, yeah, if you can believe it. I know, it's really surprising, that one. There's some really interesting work on this. So early on, there wasn't a lot of treatment option for labor pain. There was ether. So ether, I mean, it's borderline chloroform. It's just, it's nothing, come on. Yeah, ugh. And not very safe either. So John Bonica and John Bonica's wife, Emma, was pregnant and giving birth, and she had a physician who was less experienced than John, let's put it that way. He was not a very good physician. And he administered ether as she was preparing to give birth, and he did it wrong. And she started vomiting, and she was very ill and could have died. And thankfully, John was a trained anesthesiologist and was standing right there. So he was able to jump in and save her life, really. And it traumatized him. He was really upset by this, reasonably so. So he spent many, many years working on pioneering new methods of managing pain during labor. And he actually invented the lumbar epidural that is even used today, which is kind of fascinating. But there's lots of research into different ways of coping with pain during childbirth. So during my master's, I studied some methods where different treatments were combined together to try to enhance the overall effect. And so one of the options was using hypnosis. And so people would use hypnosis to try to make people feel more relaxed, more focused, less distracted by things going on around them, and more present in their current state of safety. And combining that with regular medical care is actually reasonably effective, but there are lots of other examples of combining treatments or using different treatments or modalities to manage pain during labor pain. But that's a perplexing one. There's a lot of great research even still going on about that, and an area where we're still learning more about how to manage that and what to do about that, because it's really profound. Yeah, great question. Yes?
What about meditation and things?
Yeah, meditation and pain. So I'm actually giving a talk about that tomorrow.
And Monica will be there.
Oh, great, wonderful. So you'll hear more about that. But the short answer is mindfulness meditation has been shown to absolutely benefit people with chronic pain, especially. I think it kind of makes sense. Because again, if we go back to the purpose of pain, pain is a protector, and it's the result of an assessment of danger and safety. Mindfulness is one way of reflecting on the state of our body, and part of that could be thinking about the balance of danger and safety in our body and connecting to that more deeply. If you add in a little bit of education about what pain is and how it works, we've seen that is also very effective. Learning about pain is enough to change how we experience pain. So hopefully, this has been helpful. Excellent, I'm very glad. Well, thank you very much, everybody. Have a great night.